A cube slides down the surface of a ramp at constant velocity. What is the magnitude of the frictional force that acts on the cube due to the surface? To do this, let's quickly revise friction on an inclined plane. So we have an inclined plane with an angle of inclination as theta. And if we draw the free body diagram of the object, there will be three forces acting on the object. One is the weight of the object pointing downwards. Normal reaction is perpendicular to the inclined surface, and since the object is sliding down, see, it's given a cube is sliding down the surface of a ramp. That's why the direction of friction will be upwards, as friction will oppose the motion in this case. Now, the question is, what is the magnitude of this frictional force that is acting on the cube? So, how to approach such questions? So, the step one is the first sentence of this question. It's mentioned a cube is sliding down at constant velocity. This is the keyword. If an object is having constant velocity, remember what will be the value of acceleration? It will be zero. And since acceleration is equal to zero, we can say net force is also zero according to the Newton's second law, F net, which is equal to m into a. Since acceleration is zero, so the net force will be zero, which means if I come to this figure, all the three forces should combine to give the net result as zero. So, how to show it mathematically? So, what do we do here? We will break the mg into two components. So, how do we do that? One component of mg will go along the incline, like along this dotted line, and the other component of mg will go perpendicular to the incline. So how do we find these components? So if the angle of incline is theta, so this particular angle will also be theta. Now the component of mg, which is along this line perpendicular to the incline, will be mg cos theta, and the other component of mg, which is along the incline, that will be mg sine theta. Now, since we have deduced that the net force acting on the object is equal to zero, which means forces are actually cancelling each other out. So, if you see, the normal reaction will be equal to mg cos theta, and the value of friction will be equal to mg sine theta. So, let us write down the two equations. N is equal to mg cos theta and friction will be equal to mg sine theta. So this is the case of translational equilibrium. Translational equilibrium, if you recall, is a case where the net force acting on the object is equal to zero. Now let's go back to the question. We need to figure out which option gives the right answer. What is the magnitude of the friction? That is equal to mg sine theta, and mg sine theta is the component of mg along the incline. So if we analyze all the options, option B states the component of the weight parallel to the plane. That is the right answer, option B. Technically, option B is mg sine theta. Now, in the question, since theta was not given, we had assumed it just for the sake of understanding. Just to complete the analysis, let us look at other options. A. According to A, the friction will be equal to weight according to A, which is definitely not right because friction was mg sine theta. So friction is actually W sine theta. So option A, that is why was incorrect. In option C, it states the component of weight which is perpendicular to the plane, that is mg cos theta. Mg cos theta is equal to the normal reaction and not friction. So C is also incorrect. In option D, it states the component of the normal reaction at the surface parallel to the plane. So is friction equal to this particular component of normal reaction which is parallel to the plane? To analyze this, let me draw the same figure again. So according to option D, we need the component of normal reaction which is parallel to the plane. How do we do that? And okay, let's draw an arrow. So we need the normal reaction component along this arrow. For that, we need this angle, and this angle will be 90 degrees. Hence, now we can write that the component of normal reaction along this arrow should be n cos 90. N cos 90 is equal to 0 because cos 90 is 0. Hence, the component of normal reaction which is parallel to the plane is actually 0 and friction is not 0. Hence, even option D is incorrect. And that's how we solve question of this type.